Hey guys, this is Mr. Quiones here to give you a little bit of a better explanation of what linear regression and line of best fit are. So first of all, let's go to a website called GeoGebra, and this is free, and you can go to it. You can watch this first and then try it yourself, and we just press start creating. So the idea here is that, with algebra, the idea here is that we're going to have a bunch of points. For example, we did the exercise of measuring our height and comparing it to the measurement of our forearm. So let's enter some data. So let's right click, maybe not that, go to this menu bar. You can zoom in a little better. Go right here, these little dots, and we need a spreadsheet. And right here we could put there was the height. Okay, we have the height. Oh, can't see those names very well. All right, well, no problem. We had the height, and then we had the forearm, okay, length. All right, so one of the measurements we had was somebody was, I don't know, 62 inches or 63, and their arm was 8. And another person had 62, and then they also had 8. And then a taller person was 68, and theirs was, let's say, 10. And we had somebody who was 72, and they had 11. And somebody was 65, and 9, and somebody who was 74, and they had 11.5. Let's put one more, somebody who was 58, and let's say they were 7. All right, I don't remember the exact numbers, but let's say this are the ones. So we're going to compare the height to the forearms. So we're going to see how related they are, how correlated they are. So after you type them in, just drag them, okay? Drag the data, both columns. You don't have to get the height. Whoops. Drag this. Right click, and we want to create a list, okay? A list of points. All right, and there it is, there's our list of points. It's list number 1. And now we can kind of move this over here. Let's see if it drew those dots. And look at that, it sure did. It put the dots. As you can see, it looks like I should have put the height here and then the forearm here. So let's change that. See the difference of that. All right, I'm just gonna copy this and put it over here, and then copy this one and put it over here. And then copy this one again and put it back over here. Okay, so now I have that. Okay, all right, so now let's do that again. Okay, so right click, drag that, and let's make that list, create list of points. And now we have our list here. Okay, we can draw this a little better here. It looks like we can see that you can see the relationship is kind of you know, so we can move some of these around, you know, just pretend that we're like that. All right, so and look at this, when I move them around, my data changes. So the idea is we want to create a line of best fit, the line that goes through here. So you might think, well, why don't we just draw the line? Yeah, we could do that. Here's a line that kind of fits through there. Whoops. Okay. But the computer actually has a way to do that, so does your calculator. So all you gotta do is go to the input field in GeoGebra over here, and what you're gonna do is you're gonna put this command, fit, you see how the fit line, so that's the command fit line, and then we're gonna put brackets and type list 1. List 1. Okay, and enter. All right, so I've tapped enter, and what the computer did, and so does your calculator, is it'll give you the line that best fits that. And as you can see earlier, I had drawn some other line that I thought was, that was more this way, but you know, whatever, mine was close, okay? But this is actually the line of best fit, would be this one right here. Okay, I'm gonna delete that one right there. So this is the line of best fit. This is the line that goes through the points the best, okay? Now, the computer actually gives you the equation right here. So y equals 2.4x plus 42, which means that for every inch that the forearm increases, generally you are 2.4 inches taller. So as you can see, taller people have longer forearms, and vice versa. Shorter people have shorter forearms. So the idea is that a linear regression creates the line that best fits through the points, and now you can make predictions. So for example, somebody with a 20-inch forearm, let's say right here, would be 90 inches tall. See this right here? 20 inches and 90 inches. That's the idea. So if you wanted to see how big a giant would be, all you gotta do is measure his forearm. You can kind of make a prediction of that. Now, so this is the equation right here. This is called a slope and intercept form because it has the slope and the intercept. And the other way to look at this would be to see it in standard form. I don't know if you can do that. No big deal. All right, now watch this. I'm going to move these points around just so you can see. And the line moves. So if some of these points were more spread out, now let's pretend it's some other kind of data. See? So as the points get more spread out, the line has to readjust itself. Can you see that? So now if you think of it, there was different kind of data. I mean, maybe it's not height anymore. Maybe it's, you know, the more years you've practiced baseball, the further your more home runs you make or something like that. I don't know. So maybe you could have like this guy, all right? Or you can make it go down. So let's see some relationship where they're going down, okay? This one doesn't have the R value. Let's see if I can find it. Coefficient, it's called R value. Yeah, it doesn't have the R value. I'm sure it has it somewhere. I'll find that later. The idea is the more close they are to the line, the more predictable it is. And the further they are from the line, so this one right here would have a negative coefficient because it's going down. And it's going to have a negative R value because the line's going down. And this point over here would have a line going right here. The line is horizontal. You see that? Y equals 69. It means you can't really predict what the next point will be. Okay? But some are up and some are down. And they're not really going up in general because some of these are bringing it down. Watch this. If you bring one of these guys down, look, this one doesn't do anything no matter where I put it. Look at that. See? And this one looks like it does something right here. This one can bring it down or it can bring it up. So this I one doesn't seem like it does anything. So it looks like perhaps the numbers in the beginning or the, here's A. So A definitely makes it go up or down. And F is the last number, definitely makes it go up or down. And the middle number will probably be like D. See that? So the middle number, look over here where the middle number changes. See that? This one doesn't really make it go up or down that much. Okay? It's just kind of more of like an outlier-ish type. But the first number definitely will. So it'll depend. If the first number is really high, it looks like it's going down. If the first number is really low, it looks like it's going up. All right, guys, so play with this, and so you can understand the simple idea of linear regression and what a line of best fit, which is called the linear regression line. It's also called the line of best fit. And the equation is called the linear regression. So don't get tripped up by the fancy names. Understand what they do, what they mean, and then the fancy names will be no big deal. Okay? All right. Hope this is helpful.